Imagine the thrill of exploring worlds beyond our solar system. We're talking about exoplanets, celestial bodies orbiting stars just like our sun, but light years away from us. Isn't it fascinating to think about what lies beyond our own cosmic neighborhood? So, what exactly are these exoplanets? Imagine our home Earth, nestled comfortably in the vast cosmos, circling around our very own star, the Sun. Now, picture countless other Earths, each tethered to its own unique star, scattered across the unimaginable expanse of the universe. This, in essence, is what exoplanets are, planets that orbit stars beyond our solar system. In many ways, exoplanets are like the planets we're familiar with. They're celestial bodies caught in the gravitational grip of a star, forever circling in a cosmic dance. But the beauty of exoplanets lies in their sheer diversity, reflecting the boundless variety of the cosmos itself. Some exoplanets are gas giants, much like Jupiter and Saturn in our own solar system. These behemoths are primarily composed of hydrogen and helium, with swirling storms that could swallow Earth whole. Their turbulent atmospheres are often adorned with mesmerizing bands of color, an interplay of intense pressure and temperature. Then, we have the ice giants. These exoplanets, akin to Uranus and Neptune, are dominated by icy materials like water, ammonia, and methane. Unlike their gas giant cousins, these worlds have a solid core, shrouded in thick, icy atmospheres that can plunge to unimaginably cold temperatures. And let's not forget the rocky planets. Similar to Earth, Venus, and Mars, these exoplanets are composed primarily of rock and metal. They often have a solid surface you could hypothetically stand on, with towering mountains, yawning chasms, and perhaps even flowing rivers. Lastly, we have the dwarf planets, small and often overlooked, but no less intriguing. These are worlds not massive enough to clear their orbit of other debris, yet they still possess enough gravity to maintain a spherical shape. Each of these diverse exoplanets offers a tantalizing glimpse into the possibilities of the cosmos, a testament to the infinite variety and wonder of the universe. They are distant, yet somehow familiar, echoing the planets of our own solar system while promising new, unexplored frontiers. Exoplanets are as diverse and mysterious as the stars they orbit. But how do scientists find these distant worlds? Well, it's a fascinating process that involves a keen eye, advanced technology, and a whole lot of patience. The hunt for exoplanets is a complex game of cosmic hide-and-seek, and it's all about the methods we use to spot these elusive celestial bodies. The first method we'll look at is the transit method. Imagine you're watching a distant star, and suddenly you notice it dims ever so slightly before brightening again. This tiny dip in brightness could be an exoplanet crossing or transiting in front of the star. By observing these transits, scientists can glean important information about the exoplanet, such as its size and its orbit's length. It's like a celestial game of shadow puppetry, with the exoplanet casting a dim, fleeting shadow as it passes in front of its host star. Then, there's the Doppler spectroscopy, also known as the radial velocity method. This method looks at the small shifts in the color of a star's light, caused by the gravitational tug of an orbiting exoplanet. When the star moves towards us, its light shifts to the blue end of the spectrum, and when it moves away, it shifts to the red. These subtle color shifts can tell us a lot about the exoplanet, such as its mass and how quickly it's orbiting the star. These two methods, among others, have revolutionized our quest for exoplanets. They've allowed us to discover thousands of these distant worlds, each one a new piece in the grand cosmic puzzle. From gas giants larger than Jupiter to rocky planets that could be our Earth's twin, the variety of exoplanets discovered is truly staggering. But let's not forget, this is no easy feat. Detecting these distant worlds is a challenge of astronomical proportions. With the vastness of the cosmos, the search for exoplanets is like searching for a particular grain of sand on a beach that stretches across the universe. Finding an exoplanet is like finding a needle in a cosmic haystack. Could any of these exoplanets support life? This question has been echoing in the minds of scientists, astronomers, and curious minds alike. The search for habitable exoplanets is a thrilling quest, a cosmic treasure hunt, if you will. To understand this search, let's first talk about the concept of the habitable zone, or, as it's more affectionately known, the Goldilocks zone. It's the perfect porridge of planetary conditions, where a planet is not too close to its star, causing scorching temperatures, and not too far, where it would be freezing. In this just right zone, a planet could potentially harbor liquid water, a fundamental ingredient for life as we know it. But the Goldilocks zone is just one piece of the puzzle. There are several other conditions necessary for a planet to be considered habitable. For instance, the planet should have a stable orbit to ensure consistent climatic conditions. It also needs to be of the right size, preferably similar to Earth, to have a strong enough gravitational pull to retain an atmosphere. Additionally, the planet's atmosphere plays a critical role. The presence of certain gases like oxygen and carbon dioxide not only provide the air we breathe, but also act as a blanket, trapping just enough of the sun's heat to maintain a life-supporting climate. The composition of the planet's surface is important too. Rocky planets like Earth are considered more likely to be habitable than gas giants. Moreover, plate tectonics, which recycle minerals and release heat from a planet's interior, are also thought to be crucial for life. However, let's remember that these are conditions necessary for life as we understand it. The universe may hold surprises, with life forms thriving in environments vastly different from our own earthly conditions. So, the search for habitable worlds is a complex and thrilling endeavor. It challenges our understanding of life and the universe, pushing us to think beyond what we know and where we come from. The search for life beyond Earth continues to fuel our exploration of exoplanets. What's the latest in exoplanet exploration, you ask? Well, let's take a quick dive into the realm of the unknown. In recent years, we've had some thrilling breakthroughs. Just last year, scientists confirmed the existence of an Earth-sized exoplanet orbiting in the habitable zone of a star called Proxima Centauri, the nearest star to our Sun. This discovery has ignited the imagination of scientists and space enthusiasts alike, kindling the hope of finding life beyond our solar system. Another exciting discovery is the exoplanet K218b, which not only resides in the habitable zone of its star, but also has water vapor in its atmosphere. A first of its kind, this discovery has opened up a whole new avenue in our quest for habitable worlds. But we're not stopping there. The future of exoplanet exploration looks promising with several missions lined up. The James Webb Space Telescope, set to launch soon, will revolutionize our understanding of exoplanets. With its unprecedented resolution and sensitivity, it will peer into the atmospheres of exoplanets, looking for signs of life. NASA's upcoming mission, the Planetary Transits and Oscillations of Stars, or PLATO, aims to find and study a large number of exoplanets around nearby stars. It will focus on terrestrial planets in the habitable zone, where conditions might be right for life as we know it. The European Space Agency's Ariel mission, set for a mid-20s launch, will also study what exoplanets' atmospheres are made of, how they change over time, and how they are affected by their host star. These future missions, coupled with the strides we're making in technology and our understanding of exoplanets, suggest that we are on the brink of even more exciting discoveries. Who knows what mysteries we will uncover in the years to come? The universe is vast, and our search for exoplanets is just beginning. We stand on the edge of a new frontier, ready to delve deeper into the cosmos and unravel the secrets of the universe. As we continue our journey, each discovery, each revelation brings us one step closer to answering the age-old question: are we alone in the universe? The universe is vast, and our search for exoplanets is just beginning. Our journey to distant worlds has just begun. And what a journey it's been, traversing the cosmic ocean, uncovering the secrets of exoplanets. We've delved into the intrigue of these distant worlds, their variety and vastness challenging our understanding of the universe. We've explored the methods scientists use to detect these celestial bodies, from the transit method to radial velocity, each technique offering a glimpse into the cosmos's hidden corners. We've embarked on the hunt for habitable worlds, the tantalizing possibility of life beyond Earth driving us ever forward. And with the latest discoveries and future missions, our voyage into the unknown continues. As we continue to explore the cosmos, who knows what new worlds we'll discover next?